Good evening, everybody. Welcome to the show. It is Friday night. It is March 22nd, 2024. I'm your host, Mike from Faraday Research. We also have on call tonight, we have Philip live from Montreal joining us. And yeah, we're going to get right into it. Started a little bit late. I actually made a mistake. I forgot to hit the start button. So, anyways, yeah, it was a busy week. I was doing a lot of experiments on the Renegade device, and so I was doing that, and then I was also following some stuff Joe Legacy was doing on his site. He's building a Zamboni battery, and I actually tried to replicate what he did, so I actually have it setting right now. So we'll get into that. What the Zamboni battery is, he's an Italian guy back in the 1700s, developed an electrostatic battery. This is ultimately he called it the Zamboni battery, and it's a pile of different materials. He was using zinc and he was using copper, manganese dioxide soaked with paper. He was making these stacks and just stacking them on top of each other, right? So, oh, Lulu's online. We'll get her on. Lulu, if you want to join us, the link is there. If you want to join us in the show, that'd be great. So yeah, so is these piles. So they have them in a museum right now. They've been in operation for 173 years. These things have been working, and they're estimating the two cells together are putting out about 2,000 volts. So super high voltage, but very low current. Which interesting about the design, it's made to last for a long, long, long time. So they would coat the outside with wax, beeswax, and a couple other materials, and they would wrap up the cells so no moisture would actually get in. They have to stay very, very dry. If it gets humid, then the power goes down. So, anyways, they have it in a museum. It has like a little pendulum ball that swings back and forth between the two stacks, piles, and yeah, they've been running for 173 years. So I'm working on that project as well as all the stuff on the Renegade. Philip, thanks for coming. And yeah, it's snowing here in Toronto. We got a storm. It's well, it's supposed to be spring, but I think it's coming back with a vengeance. Making one more sneak peek here in Toronto. So it's snowing outside. We're doing the show. Things are going to get interesting tonight. Maybe you can give us a little update on your experiments, Philip.
Yeah, thanks. Um, Actually, I performed the experiment yesterday. Um, I'll show it right now. Share screen.
Yep. Right.
So, so yeah, can you see that?
Yep.
Yeah. So that's the actual experiment, but the balance is not precise enough. There's a lot of current. There's like 80 amps going through the liquid metal vortex.
Hmm. Yeah, I've
It's
seen it.
not it's not leaking anymore. So it works pretty well because we had a lot of problems. And
That's bismuth, right? You're using the bismuth.
sorry,
You're using bismuth.
um,
What's the material you're using inside the bismuth or
it's gallium.
oh, gallium. Gallium. Okay.
Yeah. So
Okay.
yeah. So
Yeah,
that's gallium. We have a seal cover. The last time was leaking, so it had a seal cover. It needs to be screwed properly as well,
right.
and it's very no room for mistakes.
Right.
And yeah, I'll show play it right now. Um,
What's the material made out of? Like the casing is what 3D printed or
yeah, it's 3D printed. I had to 3D print it a couple of times, and now the top cover there's no opening, so the gallium cannot get out. There's no way, so it's pretty sealed. It's pretty much sealed, and I'm using a car battery charger
Right.
for the current, so I
Okay.
can go to around 80 to 100 amps,
Wow.
and even more than that for a few seconds, maybe 200 amps for a few
Okay.
seconds. But the balance is not precise, so I'm gonna go back to my good old triple beam OHAS balance,
Right.
which can measure better shift. But my I just went to the Best Buy and Stokes tonight. Tried to buy a kitchen scale because kitchen scales are digital, but they're pretty precise. But
Yeah.
apparently, they cannot go up to more than 5 kilograms. Unfortunately, the apparatus I have is 6 kilograms,
Right.
so slightly over the limit of a kitchen scale.
Right.
So yeah, so that's why I'm rolling back to my good old triple beam OHAS balance.
Yeah.
So I was setting that up tonight, and I fell asleep. So uh, I'll do it this weekend, but not tonight, unfortunately.
Yeah. Just a program notice next week is Good Friday, so we won't be doing a show next Friday. But the week after that, we'll do our regular podcast as usual. How's it going, Mike? Welcome to the show.
What's
Can't
up,
hear you.
guys?
Hey, there you go. Yeah, we're good. We're good. Lulu, I know you're online. If you want to join us, you can. The link is in the live chat there. Bernie says he's going to join us about 15, 20 minutes. So we'll see if that happens. Hopefully, Gerald's going to log in too. I know he's been working on some stuff as well. So wait for that. I'm going to send him another invite here. Maybe he's just running a little bit late. And yeah.
So yeah, that's the Canadian APEC, huh?
Yeah, yeah, the Canadian APEC. Well, minus Mike. Mike's not
Yeah,
Canadian. And Lulu's from Texas. That's all.
yeah. Gerald is not here tonight.
He wasn't here last night. He was out of town, and stuff like that happens. That's cool. I said, come on tonight. So I just sent him another invite again. So hopefully he will catch that soon and get online with us. Curious to see what he's been up to last couple of weeks since we talked. So yeah, these. Oh yeah, I want to show the Zamboni battery I'm making. Hold on 1 second.
The Zamboni
So
battery. I've heard of that
yeah,
before.
yeah. So this is the cell here. It's polyethylene glycol 3350 and carbon activated carbon graphite. And yeah, so I'm using that. It's got a set. So after you mix the stuff, it's got a set, and it'll actually go solid state. It's a solid state electrolyte. So as soon as that happens, then I'll be able to do some testing with it. I might even have to scrap it and start from scratch again and add some other chemicals to the mix. But yeah, so I got two. I don't know if you can see them too well. I got the carbon activated carbon graphite pads there, and they're in the solution. I just kind of used a little plastic cup, mixed up the and oh yeah, the material comes from an laxative. The laxative contains um, polyethylene glycol. So yeah, Zamboni built this battery back in the 1700s, 1740, I think it was 1730, and they have it in the museum. And it still works. 173 years later. So they do last an extremely long time.
Oh, that's
They
right.
don't- So they don't give off a lot of voltage.
That's the battery that still works, right?
Yeah,
Let's
yeah,
turn them
yeah. So they got like two. He made it in two piles. He's got this little metal pendulum in between the two anode cathode of the Zamboni, and then every time it discharges, it bounces the ball in between the two like a pendulum. And it's been running for a century and almost a century and 3/4, so almost 2 centuries. So another 25 years, it'll be 2 centuries that the battery's been in operation. But it has to stay in a dry area. It can't be like damp. Apparently, it loses its static charge if it's too damp. So, yeah, that's what I've been working on. So, I ordered the carbon activated carbon pads. They're like filters, I guess. They're used for filter systems. So, I ordered some. I'll be experimenting with different concoctions and different electrolyte mixtures. And I want to make it like a dry cell, right? Something that's not going to be a mess. It's going to dry up into like a plaster of Paris, kind of brittle. It's kind of brittle. So yeah, we'll see what happens with this, and I'll do some testing with it. I know Joe Legacy, he gave me the idea on how to do it, so you can check out his YouTube channel as well. He's got some really good stuff up there. So what have you been up to in the last week, Mike?
Nothing electronically.
No, still
Just
working on
ordered
the
some
house.
parts. I got myself the double pull, double throw
Oh,
relay.
there you go. Yeah, I've seen those. Yep.
Just figured out with there's a little metal thing that comes with it. If you see that
Okay.
little metal,
Oh, okay. What's that?
it just holds it in there. So I guess it pops out.
It's a clip, yeah, to hold it.
So the relay pops into here. The
Right.
pins pop into this thing,
hmm
and you got
That's a latching relay or just a regular
double
relay?
pull, double throw.
Oh, okay. Yeah,
You
it's
got
good.
your
How many amps
your
can that
screw hole. You
handle?
could put wires right in there. No soldering needed.
Yeah, you just screwed into place. Yeah. How many
So,
amps is that one rated for?
12 amps. Let me see here. 12 amps, 400 volts.
Oh yeah. Right on.
And I'm going to use this $10 foil
Oh yeah,
from
yeah.
Amazon.
Oh, that was the one you were telling Lulu about. Hi, Lulu.
Hi.
How are you?
The core goes in and out. Hey, Lulu. And I think, is that the one you got? The function generator?
It's similar. Mine's a little bit different than that one, but yeah, it's basically the same thing. Mine's
This
got
was
a
like
box around it.
$6.
Yeah, they're cheap. They're
Couldn't
super
believe it.
cheap. Yep, they're very
Well,
cool
anyway,
to
you
work
can
with.
manually set your frequency on it.
Yeah, frequency, duty cycle, everything. Yeah, they're really, really easy to work with. Just make sure you don't put too much voltage in it.
A
I
lot
use
easier than an Adreno.
Yeah, well, I use a 9-volt battery to run those, and they seem to work just fine. And then you could use that to, use a trigger relay or whatever. Yep, very cool. You can do a lot of experiments with that. I did some flyback experiments a week ago with that, and it works well. You just got to find the sweet spot, get it into resonance, and you can light up light bulbs with very, very little power. As long as you got a big enough inductor that you'll have enough flyback, and yeah, you can light up light bulbs with it. Yep. So what have you been up to, Lulu? She there? Where's Lulu? Or she's probably just in the background.
I'm listening. I'm
Oh.
listening. Just getting my kids ready to. They're gonna go to their dad. So yeah.
All right. How's your week been?
Busy.
Yeah.
Studying for to become a licensed insurance agent for health and life,
Uh,
and hopefully happiness with that too.
mm,
Yeah.
no doubt. Yeah, we're next week. We won't be doing a show because it's Good Friday.
Yeah.
We will be doing a show the week after, so give everybody a bit of a break and enjoy your family time. And in between that time, I'll be doing experiments when I do have some free time. We got some more 3D printing I have to do this week. I've been busy with that. So yeah, there's always something to do. Hopefully
Yeah,
we
maybe
get
I can show what I was setting up earlier tonight before I fell asleep. I'll just
it's okay. You're allowed to fall asleep once in a while.
yeah. So here's the yeah. So that's the apparatus. I'm using the Orange balance, triple
Oh,
beam
great.
balance. But it's the apparatus is so heavy that I need to add like weights on the other end of the balance to balance it up.
Right. That's a lot of weight you got on there.
Yeah, it's 5 kilograms, 6 kilograms. I need to balance for up to 6 kilograms on the other end. So I added other weights, gallium and stuff. And it's still not enough. I still need to add some stuff to it.
I have
But
actually, I think I have some gallium myself. It's a really weird substance, really strange to work with. Is the fact that it solidifies just by heating it up in your hand. It just starts falling apart. It's really weird consistency to it.
yeah, it's I spilled it all over the place over the last the last year. I had to clean it up, but it's easy to clean up. All you have
Right,
to do is wait until it becomes solid,
right.
and then you just pick up the piece of gallium and put it back in the
So you
jar of
cool it.
gallium.
So you cool it off, right? And then
Yeah,
when it's
exactly.
solid. Cool. Good to know in case I drop it one day.
Yeah, and it's not
I can't
toxic. So,
remember. I can't remember. The gallium and the mercury were like similar. That's why you chose gallium.
Yeah, but well, gallium's a lot less toxic, right, Philip?
mercury is toxic, not
No,
gallium.
no, that's what I'm saying. Gallium's a
I
lot
know,
safer
but
to
that's why
work
you
with.
chose the gallium because it's not toxic, but it has the same properties that you're looking for as the
Yeah, but
mercury.
mercury is a little bit better electric conductor, slightly better than gallium, so it's more efficient to use mercury than gallium. But
Uh-huh.
there are alloys you can use instead of gallium, like gallium or something like that, that are better
Alloys.
electric conductors.
But a liquid like a water and salt is not. It's not gonna work. You're saying
No, it needs to be heavy because it needs to generate gravitomagnetic field.
heavy. Like
Yeah, it needs to be heavy.
what about deuterium? Heavy water.
I don't know. I don't have a I don't have access to a nuclear lab here.
Well, no, you don't need.
Well,
It's
you can
just
do
heavy
it with
water. I
electrolysis.
guess you do need access to.
Well, you could do it with electrolysis. It just takes forever to do. You got to
Right.
keep cycling
Yeah,
it,
right. You can
cycling
do
it,
that too.
cycling it over and over and over. Gerald could tell you all about that.
You pump hydrogen
But-
into it.
Well, you're just recycling the same water you used from before, and you just
No,
add a
that's
little bit
light
to it.
water. That's removing the deuterium. That what you're talking about with distillation or
No,
What
with
is
the
it?
electrolysis, when you're actually doing electrolysis, if you keep reusing.
okay,
the
when you
same
do
water-
electrolysis, you're pumping the hydrogen in the water, making it heavy
Right.
with
right,
hydrogen.
and you keep going with it over and over and over again, and it gets
Right.
heavier and heavier. To the
I guess it's
point
probably illegal to even make that stuff. No?
No, it isn't. It isn't. because any Joe Blow could do electrolysis in their house.
Right, that's what I'm thinking.
You know what I
Hey,
mean?
so you can make heavy water. It's water, and it's heavier than regular water.
It
because
actually
has-
turned to jelly. Gerald says his actually turned to like a jelly substance after a while.
Gerald was making heavy water
Yeah,
with electrolysis.
Yeah.
Huh.
so yeah, Bernie.
You
said
too,
he made-
Bernie made some heavy water also. Huh? I gotta try that. But you can't drink that stuff. It's not good for you.
I wouldn't really recommend it.
Well, if you were to make it, it'd be for like some kind of science experiment. Like
Well,
kind
of course,
pills
that's
do.
the whole point because eventually that heavy water changes to deuterium, and you get some radioactive properties there.
Hmm.
So, yeah, Bernie says he doesn't drink it. That's good.
Yeah,
That's
you do
good.
not drink heavy water, folks.
Not
Do
recommended.
not. Light
Unless you-
water is what you want to drink. Is when they remove the deuterium from the water it's already in water naturally. Deuterium.
Well, if you want to do an experiment, you drink it. You want to see if you want to glow at nighttime. I don't think you want to do that though. Not recommended. Yeah, actually, I pulled out one of my old devices today just for kicks. I wanted to run it for a little bit. My Don Smith generator. The thing still works.
Oh, you got one of those made?
I made it.
Did it work?
Yeah, of course it works. Actually, if you guys hang tight, I could show you. I could pull it out and show you.
Yeah,
So it was worth making.
Yeah, all right. Give me a couple seconds here. You guys chit chat and I'll bring it out.
I love seeing devices like when people build devices. I think it's the coolest thing.
It's prototypes.
Yeah.
Hopefully.
When it works, it's even better.
You think, a device you're making is a prototype until you make it, and then sooner or later you figure out it's been made somewhere else, But it's not popular knowledge or something like that. It's not mass produced or nothing.
Yeah. Yeah.
Phil, I have a question.
Like,
What is your Mercury vortex supposed to really do? Like, could you explain to me, like, just a bit, like, pretend I'm a person that does not know anything, and you're trying to explain this to a person that doesn't know anything. What is it supposed to do?
I believe he's trying to generate centrifugal, no, Phil?
Well, it's supposed to generate gravitomagnetism, which is energy density, and I'm trying to prove that that's what gravity is. Gravity is just any form of energy density that you can create artificially, and gravitomagnetic force is it's kind of a force that is there, but nature doesn't use it, and we can just harness it artificially. So that's what I'm trying to prove.
It's not centrifugal?
So it's like the difference in flux of resonance, or is that like the difference is what you're trying to extract the energy
Yeah, it's like in any well, the centrifugal, to answer your question, Mike, it's that's the gallium. A mass in motion will generate gravitomagnetic energy density, and that's why I need something heavy. And any form of energy, light is, and that's what I'm trying to prove. Even light is gravity, like, because it's a electromagnetic force. Energy density, sorry. Gravitomagnetism is an energy density. Gravity is an energy density, and that's what gravity is. That's what I'm trying to prove, and we can create tractor beams because using just standard electromagnetic beams because of of low frequency but high energy density, because that will induce time dilation, so that will freeze whatever is inside that beam. You understand? Because of
What
the time
about
dilation, everything
what
within that
about
beam.
what about low energy density, high frequency?
Yeah, that's just fatal. That's gonna kill somebody, and it's not gonna induce time dilation. But
No, I mean for tractor beam. For tractor beam, low energy density, high frequency.
no, that's not gonna work. And you need because
You need the high
one.
energy density.
Yeah, but you need the beam to go through the person. If you have high energy,
Mm.
high frequency is gonna be reflected by the body. You understand?
Mm-hmm.
If you use like low
That's why you're doing low
frequency,
frequency.
if you use low frequency like radio waves, it's gonna go through the body or the wall or whatever, and that's what we want. You know, we want the beam
Good
to go.
answer, Bill.
Yeah,
Good one. Makes
All
perfect
right.
sense.
yeah,
Here's the
You need the high energy density to go through the body to get the tractor beam effect.
yeah. You need low frequency to go through the body, and high energy
High energy.
density to induce time dilation
And with the
to
low
freeze.
frequency, there's no harmful events to the body in that
No,
tractor beam effect
it's perfectly safe.
because it's low frequency.
Yeah, exactly.
I
It's
guess.
like
I mean
radio
that
waves.
in some aspects that makes sense.
Yeah, it's like radio waves are not fatal at all. You know,
Hmm.
they're harmless.
Right.
well, if you
And you
guys are
couldn't do it
ready,
with low energy density, low frequency.
Yeah, exactly.
so here's
Uh,
my Don Smith device. If you want me to go over it, I'll show you all the parts and then I'll run it for you. So I got the power switch on and off. This is the high voltage module that'll put out 11 kVA. And then it goes through two capacitors. They're 15 kVA each. Goes through the circuit, goes through the first spark gap, comes out, goes to the second spark gap, goes through the positive of the light bulb. This is a 25 watt. Comes out the negative of the other side. And that goes through the second spark gap and then down to ground. That's
There's
the
two spark gaps.
yeah, I put a double spark gap in there.
Oh,
So I'll just
that's not in the device. You just added it. Okay.
no, I added it. There we go. And then you can see the spark going. I don't want to get too close. Can you see the spark going there?
Mhm.
Get that.
You got one on each pole, the spark gap.
No, it's in series. Yeah, two double spark gap in series.
On the positive leg.
Yeah, just go straight through. Zigzag, come through the bulb, down the ground. Very simple circuit.
Right, in series, but one on each pole, one on the negative and one on the positive.
No,
In and out.
it's one basically like one wire. So you got positive coming out, goes through the first spark gap, comes out, goes to the light, goes from ground to the
Out the
second
light to the
spark,
second spark gap.
right? And then
That's
from
the
there,
negative. No?
well, it changes. It starts off positive and ends negative.
Right.
So the last is the second spark gap before it actually goes to ground.
So you have a
So
spark gap on each pole,
mm,
positive and negative.
yeah, most people only do it on the positive. I tried on the positive and negative side, and it works just as good.
Yeah, you can
And
do that.
now I can separate the gap even larger if I want to. I can go a lot wider, and it makes a bigger frequency. Makes the light go brighter, but makes a hell of a lot more noise. So actually, I went a little too much for that light bulb. Actually, shorted it out. So I've
And
zapped my.
what are you
I've
giving
zapped
it? 10 watts or something?
about 10 watts, and it's at 10 watts it'll produce 11 kVA. So you can see the light goes pretty bright here. Actually, I'll shut the light off so it works better.
No capacitors.
Yeah, I got two capacitors, two 15 kVA. And they're right there, the two blue ones there.
Oh, the little ones.
Yeah. That's it. Very simple little circuit. Now I've hooked up transformers to this, isolation transformers, and it works even better. You can add quite a bit more lighting to it. So it's a good experiment to run, but I don't really know what's coming off those spark gaps, if it's actually harmful or enough. So I don't really use it that much. I experiment with it, once in a blue moon, here and there. I'll toy around with it, but I don't have a device to actually tell me if I'm emitting something dangerous off it. So I keep it to a bare minimum. I'll play with it for a little bit here and there, but
It
they're
almost
cool.
That's
like
cool.
the when you put a distance between the spark gaps,
Yeah,
like it could become a hum,
X-ray.
like like a consistent sound where it's not so static.
Right. So I put them closer together, and the I guess you could say duty cycle will actually be a lot of faster. So, and it doesn't make that much noise. But the second you start pulling them apart, then it becomes a lot more violent. So you got to make sure your low can actually handle that. Otherwise, you could blow light bulbs. So usually in that case, I would always put it through an isolation transformer. And then that way, it's not like actually a physical direct connection. So it has a little bit more safety involved. So, and I've also charged up capacitors with it as well. Um, Faraday cage, yeah, I've used a Faraday cage with this a few times because I was kind of worried that the CRTC would come knocking at my door. So
You suppose if you put a stator coil next to that spark, you'd get, power in the stator coil.
if it creates enough a static charge, yeah, it's very possible. If I can do what, like the Tesla plasma balls do, you could put an inductor beside it and it will conduct the electricity through it. Like I've demonstrated that on my channel many, many times. It
I don't
works
see why
really,
not.
it
I don't
works
understand
really
why
well.
nobody tries experiments like that.
Oh, it works fantastic. Works really good. I've got
You're already, creating a spark to run the circuit. Why
well,
not?
I did one where I used metal plates, so I would surround the ball with metal plates, and it picks up the charge like you wouldn't believe. I could charge super caps. I could charge those big blue ones, the big oil
Disruptive
filled ones.
discharge.
Yep.
What would happen if you put it like in a vacuum, like let's say a bottle with two ends that you seal it from both, and that space and that that gap in between them is and
Well, I do have those.
vacuum.
I do have vacuum tube spark gaps. They make
There's this
awesome.
theory running around regarding vacuums is that if you have any energy inside there at all, even though there's no matter, air, or anything like that, there's energy in there. It's not a vacuum. It's not a true vacuum.
Uh,
So,
Well, the ones that I have are from old Navy battleships. I actually have the original box that these came from. They're actually issued in March of 1945. Believe it or not, it says right on the box. I got about 6 or 8 of those, and they
that's what
work
I'm
amazing.
understanding though, is if there's any energy inside that vacuum, then it's not
Well,
a vacuum.
no, they put argon. They put inert gas inside because those were used for, from what I understand, those tubes were used
To
for
remove the oxygen.
radar systems. Radar systems. They were using those tubes for. They don't make them anymore. Like these tubes are probably worth a lot of money, and I was able to get my hands on quite a few of them. I could actually show those too in a couple minutes. I can go back there and grab them. But I got it two sizes. The small ones I got, they're from 1945, and the bigger ones, I believe they're from probably the late 60s, I would say. But they're really nice, really, really nice.
Yeah, that's more like a sealed compartment with a gas in it, not necessarily a vacuum, though.
Yeah, because when mine start glowing, they glow like a purple, pink purple. So that would be argon from what I take.
Right. I mean, it's sealed, and the gas is sealed in there. But a true meaning of a vacuum means there's nothing in there. No gas, nothing. It's a vacuum. To be specific,
Well, they
that's what it's.
call it.
Not
Well,
even not even energy is supposed to be in there,
as
inside the
far as I
vacuum. To do
understand, they are.
then you put your energy
real
in the vacuum to
vacuum.
do your experiment.
These are military grade, so I take it they are probably vacuum tubes. Like I don't see them not being vacuum
Plasma
tubes.
tube.
These are all
Right.
military grade, the ones that I have, so even more so. But yeah, they're awesome to play with. I have some pictures on my YouTube channel of those spark apps in operation. It looks like they almost make like ball lightning inside. Like they create a ball in between the two inductors, the anode and
Like,
cathode. Yeah, it's really pretty to look at when they're going. Eh? They look so amazing. Even when you turn the lights out, oh, what a show! It's like a light show you've never seen. Really cool. Yeah, hang tight. I'll show you one.
The neon bulbs, you mean? So Phil,
but
you're not shooting for centrifugal effects to get to the anti-gravity. You're not like homing in on the centrifugal effect for the anti-gravity. Is that like the focus?
Oh no, that's not. That's not what I. That's what it's. That's not the mechanism. Um, the vortex is just a way to create a gravitomagnetic energy density. Um,
Right, which comes from the centrifugal effect, doesn't it? I mean, because when things spin, you get that lightning effect. I mean, not lightning as in lightning. I mean, as in losing weight effect.
yeah.
Yeah,
Um,
I don't know if you guys can see the writing on here. This is the
yeah.
original box. Look at the date.
47, 45.
Yeah, they're the originals.
old.
They've never been used. I was the first one to actually use these things since 1945. They were a surplus, came from a surplus store in Southern California. They shut it down. This old guy managed to get a whole whack of them. So this is it here.
Huh? You all right?
Cool.
So the you have your cathodes on the end, your anode be in the middle, or whatever you want to set it up. You can attach it to either one. So these are Army surplus. These are the real deal. And I also got another one too, a lot larger one. And these were used in the radar system of old battleships from 1945. Another one here. And these things were sealed pretty good too when I got them. It's like almost like some kind of burlap type. Just don't want to break it. Delicate. These ones are a lot larger. You know, the size of these guys. And they're pristine too. You could tell just by how shiny the copper is on the inside of these things.
Very well preserved.
Yeah, these things are mint, like totally mint, and they work
They
great.
didn't rust or anything.
No, nothing. There's no corrosion. Like these were like see this package? It's like a burlap, and they were an airtight seal. I had to actually physically cut them open, and they got some kind of like a silver lining on the inside, like shielded. Yeah, these things were packaged well.
Yeah.
Let's see what it says on the box. I don't know if there's So manufacturing date on this. Let's see. Oh yes, packaged on October 1956. There you go, 1956. These were packaged.
The other one said 45 on it.
45, yeah. They're quite a bit earlier. Yep.
What were they making those for back then? What were they using them on?
Well, the small ones were used in radar systems.
Oh, radar. Okay.
Yeah.
They were using that as their switch or whatever.
Switcher, they were using in something to do with the power supply for the radar countermeasures.
To the frequency operation of the radar.
Countermeasures, they called it.
Countermeasures.
So, anyways, I got about 6 of the big ones, and I got about 8 of the small ones, and they're like I've only opened these 2 packages. All the other ones are still sealed. I haven't touched them.
That's the most interesting thing, radar. Wonder who invented that.
Well, Tesla did. He was the guy who
Did he?
pretty much. Yeah. Surprise, surprise.
And I wonder how that works. You send out a signal, bounces off the craft, comes back to your receiver, and you get an image. Right, that makes sense. But I mean,
Yep.
what frequencies are they using to get such an accurate image so far away? What are the range on these radars? Like 500 miles?
See,
Or something?
back when those things were being built, don't forget he had a little bit more hardware to work with. Like, when he was in, the late 1800s, a lot of the vacuum tube stuff was just starting to get developed. So now in the early 1900s, 1920, 1925, in that range, they had some pretty good vacuum tubes, right? So he had better stuff to work with. If he had that stuff, 20 years earlier, he'd be way further along. Like
Sounds
even
like the cleaner your signal is, the further it goes.
well,
Or
disruptive discharge, it travels. That's why he was using it. And the spark.
Well, that was
gap-
his primitive way of doing radar.
Well, yeah, like he pretty much invented all that disruptive discharge technology for radio transmission, right? So as time went on, they
More like
developed
a cruise.
tubes, right? And now the tubes are, you can tune them to frequency, and now you can get those.
Yeah, you get a nice
signals
clean
way
signal, and
Right.
that's how you get a further range on.
Exactly. So it's just the technology got better over time.
The
right?
better the switching got, the cleaner the frequencies became.
Yep, and more accurate.
Yeah, but nowadays they have maybe I can show something also again. They have um, telescopic cameras where you can measure. I did the same, but they already existed. So actually, using artificial intelligence and 2 cameras, it's you can easily calculate the distance of objects,
Excuse me.
and it's real time. You don't emit any, you don't scan or anything like that, because radars are much slower because it needs to scan the whole area.
Yeah, it's just using the dimensions of an object that's already known to the database, and then doing some math.
Yeah, so you can do the same, much more in real time to calculate the
That's
distance of
crazy.
objects.
That's like
But
covert radar. You can't detect that you're being scanned with radar. With this,
Yeah.
you can just
with
from
this,
a long distance away, you can take an image from 2 telescopes. You're kidding me? And
yeah,
they can tell everything. Huh?
exactly.
There's no jamming that signal.
Yeah, it's not emitting any signal, so you cannot be detected. And it's faster.
I guess that's
So-
when clouds come in handy. Huh?
Yeah, but even when there are clouds, you can use infrared. You know what I mean? You can scan the
to
area
get the same
using
image.
infrared.
Right. My God, they thought of
Yeah.
everything, haven't they?
Yeah, so I told the command guy at the Pentagon when I was in Hawaii. I told some Air Force guy at the Pentagon about my software, but he did not get back to me. But they're fully aware of the possibility of changing radars to new types of technologies, like the one I just mentioned.
Right, because you can jam a radar signal with other signals,
Yeah.
Yeah,
and
you
with
can have there are stealth fighters that are not detectable by radars.
Yeah. They
that too.
use
But using telescopic imagery, if you can see it, you know it's there. You can tell where it is and all that.
Exactly. There's no way to hide.
yeah.
And if you
But
can't,
heat signature.
if it's and again, if it's
That
too
whole that whole the
cloudy,
whole the whole eye thing, you know, it makes a little more sense now.
Yeah.
And why they keep creating those clouds, trying to
yeah,
help
Weather
block
the,
manipulation.
spying going on,
Weather
Chinese
manipulation.
the
spying.
chemical trails they call
Yeah.
it.
The chemtrails. Yeah.
They're trying to
Yeah.
block spying satellites from other countries.
No, they're
Probably.
probably ionizing the atmosphere to make it more conductive to do whatever they're doing. Right. Makes the atmosphere more conductive.
To
Right.
send signals. I mean, if it's more conductive, then signals travel faster.
That's right. They could propagate a lot easier.
Yeah.
I
I mean,
saw something. I can't remember where, but the barium or whatever they put in the air, and they send another carrier wave that just makes everything two-dimensionally viewable
when they say bandwidth, isn't bandwidth like like higher
for
atmospheric?
the drones, so they can see everything during war. They put
Yeah.
this stuff in the air, those little particulates, because then they can send a carrier wave through everything
Yeah.
that carries through those particulates, with the metal, barium, aluminum, whatever it is. And then that carrier wave enables them to see like X-ray vision, like Superman. You can see everything without
Yeah.
infrared. It's not infrared at all. It's just using um, um, a frequency that's bouncing off everything
Yeah.
so effectively that you can see all the dimensions of everything.
Yeah. They World War
That's
II.
what I heard. Or
I think the Russians at one time were using a system called the woodpecker.
like you can see through the wall, see the person behind the wall.
That's more
Because the
excellent.
particulates are in the air inside the room behind the wall as well.
Yeah.
And little frequencies bounce through everything and out the cracks of the wall, and the signal keeps transmitting a three-dimensional image. Not the same thing as what Phil just described with the optics. This is using frequency optics to generate a different optic.
What would
Not
the
your,
blueprint of its path be using? Like metals or like?
yeah, the little metal particulates, and then they send a carrier frequency that transmit through all those metals that
Wow.
makes everything three-dimensionally viewable through a certain type of lens that they have.
So it draws up like a blueprint of the surrounding area. Interesting.
Yeah, kind of
Very
makes everything radiate with a particular frequency that a certain type of eye can see. A lens that they've created. I don't know the details on that, but I do know that's part of the whole conspiracy of why they're doing that.
Well, the other thing is too is what are the long-term health effects on us? We're breathing that stuff in, right?
Like at any moment in time with a drone, if they needed to see inside of a house through the roof and the walls, and not only that, here also they could see. They don't see you in your true color. They see you in the whatever color that the frequency generator is creating for them to see. It's like but it looks like you still look like yourself, all your dimensions and all that, and they see what's in your hands and all that stuff through the wall.
I think they're doing that with thermal imaging now,
like a
right?
heat signature.
No, this is beyond
Sure.
infrared. This is
Huh.
using signal waves, a
Yeah.
carrier wave that reflects off of these particulates that are floating in the air.
Yeah.
Okay, I've heard of a new technology that they can beam a certain frequency on objects, and they could tell you the composition of that object. For example, if you have like a bag of chips in your hand, they could tell you that that color of, like, let's say the bag of chips. It can identify what kind just from the reflect. If it's patented, stacked, manufactured, it's all, they know exactly, just from on any object, just by that reflection. Yeah, I've heard of this. But
It's very much like radar, but much more advanced.
Yeah, that's you're talking about spectronomy or spectroscopy, so something like
Just
that.
like they see under the ground with the ultrasound or whatever.
Yeah, but
You know,
that's what my employer is doing. He's able to measure the oxygen level inside the brain using spectroscopy. You know,
Right. Yeah.
so
I
he's
like to get
sending
a
a beam in the brain, and then it reflects back with information, and he can tell the amount of oxygen in the brain in real
using
time.
just a frequency generator to do that, a signal generator, and whatever reflects back
Yeah,
minus whatever signals tells him the
yeah,
oxygen
exactly. Yeah,
content.
I'm
yeah,
just
Mhm.
gonna scoot outside for a quick smoke, guys. Just carry on.
Those are the basic
like,
fundamentals of using frequencies to determine things. You send 10 kilohertz one way and you get back 9.9 kilohertz. It tells you something.
yeah, exactly. Because each atom is gonna absorb whatever colors, and then whatever color is reflect back, then it's gonna tell you the
What color the thing is.
the net
Right.
composition of the material.
Plus you got red, blue. Those all have their own frequencies. Those colors have their own.
Yeah, exactly.
We don't know them
So
offhand, but they're definitely a set frequency.
yeah, so it's my boss is doing that, and it's there's a huge demand because it can be used by
That's all optic technology, lens technology.
yeah, exactly. It can be used by astronomers, people,
Astronomers,
astronauts, sorry,
astronomers,
astronomers,
astronomers.
astronomers, um, and people who do scuba diving and all that stuff. So and jet fighter pilots to measure their concentration level and all that.
If you want to get hands-on with the most recent technology and that kind of stuff, you got to hook up with a treasure hunter. Those guys got it. Because
What is
when you're
that?
looking for gold and silver, you're getting the most advanced technology before anybody else. Treasure hunters,
yeah, it's like
anybody that's looking for treasures like gold or in the waters, gold, silver, whatever stuff like that, they got these latest technologies, that the military has. They put it that way,
Yeah,
and
you can
they're
buy.
civilians.
By the way, I've looked it up once. You could buy it I think maybe it's like $30,000-$40,000, but you could
Yeah,
literally put it on the ground, and it will tell you the composition of the elements in the ground. Like a lot of people that want to know if there's oil, like they buy big
yeah. Oil. People looking
oil.
for oil, right?
They use this little machine, but it's like 30, maybe 30, 40,000.
Prospectors.
For that. But yeah, it's available, and anybody could purchase it. It's not like just for military use. It's for commercial use as well.
But when you imagine when devices like that get to be, instead of 30, 40 grand, they get to be around, 3 to 5 grand. How
That
many people are going to be discovering oil and gold and, because these devices are everywhere. You'd be a lot more people out there looking for stuff
But
like them.
remember, the more expensive, the deeper the frequency goes into the ground. Like the ones that you're talking $3,000 to $5,000, maybe it will detect water, like a water well. But if you want to go deeper, I'm pretty sure the spectrum of frequency has to be, stronger. In order for it to penetrate through so many different layers of stuff.
And the more you increase your amplitude, the more dirty the signal gets. So you need good equipment for that to keep the signal clean as your amplitude gets up. That's the whole thing.
Yep.
Increasing your amps on that signal, but without bringing the distortion that comes with it. That's why those devices cost that much money, because they're not easy to build. When you get up to like 50 amps, like these radars are pumping out 300 amps to go 500 miles, 1,000 miles even out into the ocean.
I mean, they use it
Uh,
for like excavation and for like ancient monument detection too. Like it'll tell them the different, if there's like an ancient city or things like that. I've seen these things before, so they're pretty cool. I mean, the whole idea is pretty.
ground GPR, ground penetrating
Yeah.
radar.
Yeah. I mean, come on, how cool would that be? Like to discover something like that. I mean, I think it's pretty interesting.
What would you do if you had a GPR and you found, like, let's say, 20 bricks of gold under the ground? How would you cash in on that? You know how hard it is to get that gold converted to cash without going through all kinds of questions, interrogations.
Just smelt them. Go bring like one of those
Yeah,
big old.
that's what you have to do before you bring it in. You can't just take the gold you found in the ground. You have to turn it into a coin that somebody else recognizes.
Well, it would
Then you can
depend.
cash it in without any question.
Like, listen, it would really depend on the era. If it's something like an ancient thing, I would probably not want to. I probably want to like leave it the way it is for science. But if it's something,
And, and guess what? By smelting the gold that you found in the ground into a coin that's already recognized today, a gold coin, you're evading taxes. You find gold, even if it's in the coin that's recognized today, you have to say you found it, that it wasn't something you already earned,
Oh,
or
by the
that you're
way,
getting.
talking about gold, I think somewhere in the United States, I saw an article where they have a good source of hydrogen in natural form. So it's it can be used for hydrogen engines and stuff like that. But it's pretty expensive to carry hydrogen or convert it back and forth to transport it. But there's a huge source of hydrogen, so it's like a it's like gold, but modern gold. Let's put it that way.
When they found a hydrogen reserve somewhere,
Yeah. The
natural,
yeah, it's natural.
not natural gas or something like that. It's something different. You're saying?
Yeah, it's natural hydrogen in its pure form.
Like pure H?
Yeah. So
What?
possible just by itself. I mean, there's an abundance of hydrogen.
yeah, there's certain articles, so you can Google that. You'll see something. I can check it out right now. I'll let you know.
Is it liquid or what?
No, it also makes hydrogen too that I noticed. My carbon magnesium batteries, if I put them in water and let them sit, water bubbles start forming over the magnesium, and that's actually hydrogen reacting with the water. Hydrogen actually comes off the magnesium, which is I found pretty cool.
Is that part of its fission process? Magnesium?
Yeah, well, it's the energy, I guess, released in it, right? It's part of the composition. When it reacts with water, it releases a hydrogen.
Yeah.
The
It's part of,
electricity from the magnesium
yeah,
is breaking the water up,
yeah, it's naturally cracking
breaking the
water.
H2O.
Yeah, actually,
H2
hold on a
also.
sec. Hold on.
But that's rare that you would find pure hydrogen, a clean source of hydrogen like that, without any
I
carbon
got
in it.
my. I don't know if you could tell. If you could see all the bubbles. See my
Huh?
magnesium batteries, how they're all bubbled? That's hydrogen. That's
Yeah.
naturally producing it, just with the hydrogen, magnesium in the water. Look at all the bubbles. It's pretty cool. I've been experimenting with these batteries as well, so I've been trying to come up with a better type electrolyte so the magnesium battery lasts longer. I was able to get these ones working till about 3 days, but I still have a corrosion problem with the cathodes. I was thinking of trying a new one, and then after I put them in, put the wires on it, and then give it a layer of nail polish and put that on top. It might help with the corrosion issue, oxidation, corrosion. But they seem to, yeah, this new concoction that I came up with. Usually under regular, just
Zinc.
using regular water, it
Zinc,
would
zinc,
last. Zinc.
zinc will prevent oxidation.
Mm.
I mean, it protects the iron from oxidizing.
Yeah, I'm wondering if I could use that as a cathode or anode, I should
Yeah.
say.
Zinc.
Yeah, maybe zinc I might be able to do.
That's what they use to galvanize steel, so it doesn't rust.
Yeah.
I mean,
screws and stuff like that that you get from the hardware store.
I'm sure there's other metals that prevent oxidation, but I don't know if zinc is the best one or not. I don't know. I know it does.
Yeah, so I found the article. Actually, maybe I can share it again.
Sure.
Present share. Is it this? Sorry, I forgot. Yeah, this
What's
one.
this called again? What they call this imagery again, Phil?
No, that's
interferometry.
That's you have telescopic cameras that are able to map the depth of objects, but this one is something I program on my own. I figured out in parallel how to use some AI and 2 cameras to, just like a human. You know, we can estimate the distance, but you just do it electronically using computers.
That's scary because this is what AI drones would be using.
Yeah, exactly.
Yeah.
To police us.
Yeah, they could use it. I did try to warn the Air Force so that it's possible to do. So I don't know what their decisions are, but at least I know they know. So yeah, that's the source of hydrogen here.
An agency says that there is enough natural hydrogen easily
Put the link in
accessible
the
underground in the United
comments.
States to meet demand for hundreds of years.
Yeah, I'm not gonna show the whole video because for copyright issues.
Put the link in the chat, Phil.
Yeah.
That's a liquid pool of hydrogen. Wow.
Yeah.
Be nice to figure out how Earth is making that.
Yeah, and I mean, hydrogen is highly inflammable, so how it can stay at its natural form amazes me.
Well, it's not that flammable, and not like oxygen. Oxygen is highly flammable. Hydrogen is flammable, but it's not highly flammable.
Well, I mean, if you put a
it's
lighter,
it's less flammable than gasoline.
well, if you put a lighter, I mean, next to that source, then the whole
it won't blow up. It'll light up, but it will not explode. It'll just be a flame above the water until you get the air. There's no more air. Then you put it out by getting the air out. But it won't explode because it's not that flammable. Oxygen, though, would explode instantaneously. Boom. But hydrogen is less explosive than gasoline, and gasoline does not explode that easily.
Hydrogen implodes.
Gasoline requires a high temperature in a sealed environment, as in your motor, or a spray paint can inside of a garbage can with some heat.
Needs compression, pressure.
Right. Diesel is even less combustible than gasoline, and hydrogen is even less combustible than diesel. So it's pretty safe. Pure hydrogen is very safe.
What about
What about
Well,
what?
kerosene?
it's
Kerosene.
Kerosene's like
that's jet fuel.
it's
right?
like it's the same as diesel as far as combustibility.
Years ago, I worked at the airport, and you could smell the fuel from the airplanes. It smells exactly like kerosene. Exactly. It's pretty much what it is. Kerosene.
Like NASA was using oxygen, and that's how that disaster happened. When that astronaut got burned alive by the oxygen. What was his name?
Oh, that was in the Gemini tests. That goes way back.
Yeah, they were. That's when they quit using pure oxygen.
Yeah, because they had, I think some of the insulators they had in there was styrofoam, and basically went poof.
And these fuel cells, they separate the hydrogen and oxygen, and they don't keep the oxygen because it's too dangerous to keep it. But it's a very huge. It's got like 10 times the energy that the hydrogen has, as far as liquid goes. It's just too dangerous to hold on to it. I mean, literally, if you had a cup of liquid oxygen on your table and it did explode, your house would disappear. It would blow up with the house, you know. It's that explosive.
I've seen some videos of houses blown up with natural gas. It's pretty violent. Like
Well, that's from the
literally,
pressure of the gas.
just somebody
Well, I
leaving
guess the
underground.
pressure of there's no way for the flame to escape.
Yeah,
Gas.
well, it's
It's
confined
looking for
to
air.
space. Yeah, I've seen a couple of footage. Actually, it happened not too far from where I live a few years back. I guess they had one of those gas stoves. Somebody left it on, and
Right.
found
It'll
some
make a
sort
big
of
boom and you know the roof will pop off. But
Oh,
with oxygen, you won't have a single particle of your house left. That's what I'm talking about.
no, this
Yeah.
house totally disintegrated. It took out 3 houses. That's how
From
violent
natural
the
gas?
explosion. Yep. Oh yeah.
Man,
Took
maybe
out 3 houses.
airing this, teaching like weirdos this stuff. You know. You know.
Yeah, we're talking about combustibles.
Yeah.
Well,
Shouldn't be talking about this because there are a lot of weirdos out there. You don't want to be teaching them that stuff.
Yeah, it's like I just want to say that remember the Nazis, they were building airships using hydrogens as well.
Yeah, Hindenburg. Yeah,
Yeah.
yeah.
And
That supposedly got
Yeah.
hit by lightning.
Blimp. That
no, it was helium, wasn't it?
Nope, nope. It was hydrogen. They were using pure hydrogen for the.
And then they switched to helium.
Hindenburg. Yeah, that was later after that disaster happened. But after that happened, the whole Zeppelin industry started to collapse after that. And you know what?
All right, but you see how that Zeppelin blew up with the hydrogen? That's not like a
It got
big
hit by
boom.
lightning. It got hit by lightning.
Right.
Yeah.
But if that was oxygen in there, it would boom. You know.
Yeah.
Big difference in explosive. You know.
Yeah, personally, I think the airships are probably the best form of air travel, and they are safe. Like if you use helium now, they could go thousands and thousands of kilometers with very little fuel, and apparently the ride in it, you don't even know you're flying. Like the flight quality is just so much better. Yeah.
You've been in a blimp?
I wish. I would go in one in a second if I had the opportunity. Yeah.
I would too.
That's kind of
hot air balloon. I think there's a book traveling the world in 81 days in a hot air balloon or something like that.
Yeah, I wouldn't
there's no
do hot air
precautions in
balloon.
those things.
Yeah, I wouldn't do
Like-
hot air balloon, but I would do a blimp. Yes.
It's like planes. They got no. It
But
doesn't make any sense.
I think the airships should make a comeback because think of all the cargo, how much you can carry in those things. Thousands of tons of stuff you can carry in a blimp. They're really great for transport of heavy goods.
I think
Yeah.
it's like similar to a cruise ship, like cruise ships.
Yeah, a cruise ship in the air.
Water,
Yeah.
like a blimp would be, like a small ship in the air, not as fast as a plane, but still, you know, it's a way to move about.
Anybody know how fast those blimps go?
I have no idea.
Well, the newer ones I know can go pretty fast. Not as fast as an airplane, of course, but
About 80 miles an hour, probably.
Oh,
maybe
wow.
faster. I would say faster. I would say up to 100 kilometers an hour. Be about 80 miles per hour.
As fast as a car.
Yeah, if you could get that speed, and the thing is too, you could go thousands of kilometers with those things and use very little fuel, right? And even if you did run out of fuel, you'll still stay in the air. It's not like you're going to come crashing to the ground.
What's the FFA, right? Like, would they like
So,
would a normal person be able to, you know, build one and decide to how they want to, you know, go about?
yeah, as long as they follow all the FFA, regulations for commercial flight or whatever. Yeah, I don't see it being a problem. I think they should make a comeback, personally.
I,
You know how polluting regular aircraft are? Huge amount of pollution. You're burning kerosene, thousands of tons of kerosene in the air. And then they say the cars are bad. Well, take a look at the aircraft. They're burning kerosene in the air. And that goes everywhere. That's getting spread all over the planet. You look at some of those air maps of how many aircraft are in the air at any given time, you'd be shocked. It's crazy. The amount
I'd
of
be
air
cool,
traffic.
to extract the hydrogen from, you know, the atmosphere and
Sure,
for it to refuel itself just from, you know, without even
sure.
having to fuel it like you know, manually or by machine or anything, but just like extraction machine built, you know, part of the whole blimp thing. And
Even the air currents. That thing is big. It's gonna catch wind. A wind hits that thing, it's gonna push it, just like a sailboat, right?
I mean,
That's what those.
I thought about the whole like hydrogen extraction, like in space. You know, there are a few atoms of hydrogen per, you know, uh,
Mhm.
cubic space, you know, volume of space. And if they were able to extract that and use it as recombustion, you know, it will give thrust.
Yeah,
Yeah, I
yeah,
mean, like, I don't understand why they always like they want the nuclear stuff, you know, like to
yeah.
propel a probe or anything when it's already there is abundance of it in natural space where they could extract it and you know, use it in their combustion chambers to.
Well, their case is, the amount of money it costs to extract it doesn't justify the cost to use it. That always seems to be their scapegoat for
They're
the whole technology.
billions of dollars. Like, it's not that hard to, you know,
Yeah,
build an
which is true. Yeah,
you know, to I don't like I don't think the money is the issue. I just think the issue is not telling people that it's possibly, you know, that it could be possibly done. I think
yeah,
that's, you know, what it is, because signals ride on the hydrogen frequency line.
yeah.
So if there is a frequency line called the line, then obviously hydrogen is abundant in space, so we can use
And
that.
water comes out of water too.
Y- that too, yeah. But water, you know, like in
They
space.
they they could have been using it in cars, for a long time. I think our technology's pretty good compared to what it was 25 years ago. I think they could totally make a hydrogen car work.
Like to capture hydrogen.
Well, their thing is, it's always been the storage of the hydrogen. How do you store it safely? But all they have to use is a stuff called a metal hydride, and it's like basically it sucks up hydrogen like a water does in a sponge.
Yeah.
And to extract it, all you have to do is heat it up slightly, and the hydrogen comes out. And the best part about it is you can make a tank. You could shoot the thing with, bunch of, you could shoot it with a gun and it won't blow up because it's all fused itself in the hydride. So they use this material in nuclear bombs. That's why it's not in the mainstream, because it is regulated because of its use in nuclear munitions. So if they had that stuff commercially available and mass produce it, then the cost would come down, and then you could put this hydrogen tanks in the car and not worry about getting hit from
Not
behind and blowing up.
for
Right.
on Earth use. I'm talking about like in space use.
Any
You know,
use. Any use.
I mean, I understand on Earth it should be regulated, but when you're out of the atmosphere, now it's like, a free zone where, the whole idea is we're building these things to try to reach somewhere. Well, and
Yeah.
we want to reach it faster, and we don't want to be carrying like a bunch of fuel or this or that to be able to reach high speeds. But if the fuel is abundant out there, then like whatever earth laws, okay, I understand those, but up there now it's like, why put laws on something that only a
Yeah,
few,
it's open season out there. Yeah, you can do what you want.
you get it, like, like there, the laws out in space should not apply the same way the laws that apply on Earth.
Mm.
you know
Yep. There's a lot of technologies that they could have used and they haven't.
Yeah.
Hydrogen they could have used in cars a long, long time ago. They never did it because the oil cabal,
I just think it's not safe. Like, still, I don't think we're there, and it could be misused on Earth. But in space, I don't think it could be misused. I mean, it has one purpose and one purpose only, and it's, for propellant. That's it. Nobody's going to try to reconfigure this to hurt somebody with, or.
Yeah,
Mhm.
for sure. Anybody else have anything else they want to show today? Oh, let's see. Bear with me here for
So
a
yeah, they
second.
use hydrogen for cars. It's just a hydrocarbon. It's got carbon in there. They can take the regular fossil fuel they find today and remove all the carbon, but it's just an expensive process.
I think BMW they found a pretty efficient hydrogen engine. I can find the article again.
A pure hydrogen engine. Well, any engine will run off of pure hydrogen, actually. I mean, it's just the carbon that comes with it. Some carbon, like natural gas has less carbon than fossil fuel. That's why it burns cleaner. It's only the carbon that's the problem in the fossil fuels. Not fossil fuel is basically it's hydrogen, but it's got a bunch of carbon.
Here, I want to show Joe
Also.
Legacy's cell he's working on. Just bear with me here for a second. I want to show his video.
I saw that today. What is he using? A salt?
No, he's using laxative. It's got ethylene glycol in it. That's a solid state electrolyte. Hold on, I'll show you
Sugar.
the video here. Okay.
A sugar alcohol. That's what that is.
You guys can see that?
Sugar has a lot of carbon in it,
All right, you guys can see that?
It's twice as much hydrogen as it does carbon.
Okay, let me just play this here.
For those wondering, this is only part one. What I'm doing is trying to test various solid state electrolytes. I think I hit on something here, so I'm just testing the electrolyte properties very quickly. This is very crude and not optimal, not the way you'd want to work with. But eventually, I'd like to figure out a way to mold these into thin wafers and use this, adapt it in my final project that I'm working on. If you've been watching my earlier videos, which is a hybrid Zamboni-like pile at thousands of volts. So that's my ultimate goal. So some people have asked, what do you want to run on these? So I don't want to run anything per se, but nothing stops you or anyone else. If this is what they like and they want to just experiment with these as is, you can, but you got to understand that it will be mostly an electrostatic effect. So as is, very little current. But needless to say, it may not run big heaters and big light bulbs and whatnot, but those who follow me know that this stuff charges capacitors really quickly and can also run oscillators here. So just to give you an example of that, so here's just a regular LED running off one of the stacks here. So there's my LED. And this is disconnected right now. I was experimenting with the oscillator. It works, by the way. And it charges capacitors. So I got one cell on its own, very, very hard, by the way, all dry now. And it charges a capacitor. So now I'm at 1.37 volts. And, you know, it doesn't like running as is a motor, but through the capacitor, no problem, you see. And it holds up pretty good. So the motor runs well and it keeps the voltage up. You know, it's going to obviously go down, but the point is, you know, this is a traditional circuit. We're not doing anything, you know, fancy here. Closed loop DC motor. But the point is, all this energy comes from this cell over here, and it does very good at charging capacitors very quickly because capacitors offer very little resistance in relative to batteries, so they're easy because you're just a little bit of current for the field displacement, and once you get established that, you're good to go. That said, with this stack here, I can charge these supercapacitors here, which are 14 volts stacked. So it allows me to run 12 volts inverters like this one here, and this will run, folks, a 25 watt LED bulb for like 20 minutes, no problem, very bright. And it charges from this. Now, if you're trying to enhance, this is really crude. Again, I'm just testing the electrolyte. I want to see how long it takes to dry, what happens to the voltage, can I make it dry faster, slower? But ideally, if you're just going to stop here and you want any kind of current, what works best is to have your plates, your electrodes as close possible as they can, squished like a sandwich, yet not shorted out. So the closer they are, the more current you'll get. And this is working pretty good. You see, I'm still gunning the motor running here. And it's holding pretty good. And nothing fancy, just one capacitor at this point to help it out. Because as I've said, these things are not very good for traditional current on their own, but we can convert that to real current with the help of capacitors. And it doesn't have to be, you know, a very complicated setup either. It could be relatively straightforward and easy. So it runs motors, it runs LEDs, it stacks so charged supercapacitor banks. But again, this is not my final project. What I want to do eventually, I'm repeating myself, but I want to mold a hybrid Zamboni pile and get thousands of volts using different mechanisms, a layered of different cells, piezoelectric capacitor cells, stacked in series with electret cells, stacked in series with these crystal-like cells. But it's more polymer-based, this kind of electrolyte. You could have polymers or crystalline. I chose the polymer method. So just thought I'd clear that all out of the way because some people are like, tartar and baking soda and that sort of thing. And it's like, no, folks, I'm not trying to grow crystal here. This is a relatively spontaneous reaction. You mix it up into a paste with just water and then you let it harden. But some have suggested in an oven to harden it fast and give it a charge while it hardens. So perhaps that could align some of the molecular dipoles and would facilitate in them providing more of a potential output after. So there's several more experiments that I have yet to do. It's in the works, folks. So I know a lot of people ask questions. What if I do this? What if I do that? I'm really showing it all to you live as I'm moving along here. So a lot of it, I still don't have the answers for. So it's looking promising. I think I will be using this electrolyte mix because it's turning out well. Our motor's running very nicely here since I turned on. And you can see that it's trying to bring that, it's trying to charge it back up. These are not running the motor. I just have an LED here to show you there's something there because I charged my super caps with it. Yes, I get it. It might take 6 hours without any fancy systems. But my point here is these will re-gauge. So you could keep dumping and dumping and dumping and dumping. But again, this is not what I want to do, but I understand some people would be more than happy with this kind of a setup, or they have their own ideas. So I'd like to share all the information. I did these cells yesterday, so I had to wait for them to dry. This one was already made, so it's working very, very well. So don't mess with it if it ain't broken. So this is the one here on the motor. If I'm reading that, the motor's taking 17 MA. So again, not big current stuff, folks, as is, unless you'd modify this, because, you know, I don't know if I can find it here. If I have one, I can show you. I think I do. Because I've got these cell assemblies here for regular galvanic-like experiments here. And you see, just because it's more of a professional assembly where the anode and cathode plate are basically squished together in that configuration, I'm able to get like 500 MA. But that's because it's a more professional, constructed, crafted, versus having it all in a cupcake in the open like this, right? Just putting it out there in the perspective too, you know? So this is still running about 7 minutes. I mean, and we're still over 1 volt. So this is what I mean by self-regaging. And of course, if I drop the motor, the charge is quickly gonna start creeping back up because the cell is still doing its thing. So here it is now running through the Joule Thief. This is basically the closest equivalent of the Bedini version of his crystal battery single cell light, but I'm using a polymer-based electrolyte instead. And it's going through this, and it's holding pretty good. And very, very bright. It's very bright. And this is the other one here running beside it, just directly off the cell here. On another stack. But the Joule Thief really boosts it for single cell.
Joule Thief is like the original boost converter.
Yep. So that's what I'm working on right now. So I'm trying to replicate that. So I'm going to try a few different ways of making the electrolyte and see which one works the best. Maybe even materials for the anode and cathode. I'll experiment with different materials too. See how that works out. See if I can generate some power that way. Anybody else have anything they want to show?
Have you seen the new proposed plan? The Japanese are doing like a space elevator, like something really out of this world.
I heard about that a while back. That's been a talk for quite some time.
They're planning on, I think, on starting it like next year. So it's
Space
like,
elevator.
yeah.
That's kind of crazy.
Well, what's going to happen when the flat earthers get up on that thing?
Oh, don't even start with that, please.
Are they going to say, "See, I told you,
Ugh.
it's flat"?
Every time I see a flat Earth thing, I just cringe.
Well, they have some validity to what they're saying. I'm not saying I know the shape of the planet or the Earth,
I'm
but
not buying it.
perspective is a doozy. If you know what perspective means and what it really
So
means.
there are giant dragons at the end of the earth. Is that it?
No, perspective, man. The lights up here, as it gets higher. It's a perspective thing. It kind of when you fully visualize what perspective is doing to a light source, as it comes closer to you, that light source gets bigger. It shouldn't. First of all, a sun that is millions of miles away should not get bigger, okay? Just because it's getting brighter. And it shouldn't get brighter either.
When you're in outer space, you can't see the sun, by the way.
I'm just saying the flat earthers have some validity to what they're saying in regards to perspective, the word perspective.
I would personally, I would.
If you drive down a
more.
road at night with light posts and you see the lights, how the furthest light down looks closer to the ground. That's what I mean by perspective. And now when you consider the sun to be the light post instead of the light post, and you see how the sun gets closer to the ground as it gets further away, just like the furthest light post on a long, dark road. That furthest light post, the light, looks to be closer to the ground. So that's perspective. Now, when you fully understand that with your eyes, not your brain, your eyes start to understand perspective and see it. When your eyes see perspective and they see that perspective changing and they understand, oh, that's perspective, what I'm seeing. Then you start to look at the sun differently. You start to see how is a sun that's 8 million miles away is supposed to get brighter or even bigger. Now, of course, you can blame that on atmospheric water molecules and all kinds of crap if you want to. But during the day, every single day, rain or no rain, water or no water, humidity or no humidity, that sun is coming closer to you. And as it does, it gets bigger. That doesn't happen with a light source that's millions of miles away. So the flat earthers are saying the sun is local. It's here. It's close to us.
Here's my argument to a flat earther right now. Every single planet.
That's perspective for you.
Every single planet. Okay, every single planet in our solar system is round or close to it. All right, even the gas planets, they're round. Why would we be different than them?
Perspective. See how the light got bigger and smaller?
Yeah.
Now, how does the sun millions of miles away do the same thing? Perspective. That's perspective, what I just showed you. People don't understand that word. I didn't either, so don't feel bad. Well, I just started listening to the flat earthers, and then I understood that word.
It always looks that way when it comes up over the horizon, right? Because
but it's millions of miles away. How is it supposed to do that if it's millions of miles away? How is it supposed to get bigger? Tell me. Well, it's millions of miles away. How is it going to get bigger?
Don't forget, the atmosphere is a lot different in the air than
but don't forget, we're not getting closer to the sun. We're not getting closer to the sun. So why is it getting bigger? And the sun's not getting closer to us. So why is it getting bigger?
I'm not sure, but my guess would
perspective.
Be, okay.
It's closer than you think, the sun. It's not that far away.
It probably is, but my take on it has to do with the density of the atmosphere. So when you're looking at it, say at 12 o'clock, all right, the density of the atmosphere that it has to travel through is different than the density if you're looking at the sun as it's coming up over the horizon. Okay, the density is totally different. That's even the moon. Some nights on the full
Smaller.
moon, when it comes up over the horizon, it looks huge. And then by the time it gets up to about, say, 8 or 9 o'clock, then it looks a lot smaller because now you're looking more directly through the atmosphere with no obstructions of the atmosphere at ground level. So yeah, perspective definitely takes a part in it, but it's no further away than if it were at the horizon. It's still the same distance. And the sun, you cannot see the sun from outer space. It's an infrared light. The only time that you can physically see that light is when that infrared hits the atmosphere. That's when you're actually able to get a visual. They actually tint the windows on spacecraft so when the sun does come around, the coating on the windows of the spacecraft will actually show the sun. But in technically speaking, in deep space, you cannot see the sun or the stars at all.
I gotta
Because
say, I never would have dug into the flat Earth thing if NASA didn't fake one single video, which they did.
they
And
faked all
that's
the
where they screwed up. They faked one video,
all the
and that's
low
all it
orbit
took for a
stuff.
guy like me to do a little digging.
Yeah,
And all I had to do was dig a little bit. Didn't have to dig that hard.
I think all the moon stuff, a lot of it was faked because they didn't have the technology. Like the best one I like is when
Well, we know
the
one
moon
video, one old video was faked. One, for sure. The new ones, we also have evidence of fakery and with green screens and stuff like that. They're
probably
coming out with that all the time. But I
Yeah,
don't
they
need.
wanted to win the Cold War or something like that.
Yeah, it's all about who can get to do what first, be first in line.
it's all trickery. You can't trust like NASA stands for never a straight answer. So that's going to tell you something right there. That they'll cheat, right? Like perfect example, the moon lander when it was taken off to go back to the Earth. Okay, my question is, who's the guy on the planet on the moon taking the videotape
Taking
of
the
it taking off?
picture, right?
Who's there? Did they leave somebody behind that I don't know? Like, how the heck did they do that? Like right there, I was suspicious. As soon as I saw that footage, I go, okay, who's doing that video? I think they faked a lot of it because they didn't have the camera technology to actually pull that off. Because if you take regular film, all right, you put it on an aircraft, and then you go through the Van Allen belt, guess what happens to the film? It gets destroyed.
Well, they could have done that with wireless at short
No,
range
no,
onto the craft that was taking.
I don't think they have the technology to do it. I really didn't.
Oh, they did.
Not
Yeah,
video. They could do
They're
audio.
broadcasting TV in the 50s. Why couldn't they do it on a
Yeah,
little
but not
capacitor,
in, like in
inductor?
real time. They were showing
In real
stuff
time.
supposedly it was in real time. I don't believe that at all. I believe they could have did
But
audio, yes, not video.
right. But there's more solid proof of fakery than that. That's just, coincidental, evidence. But there's solid proof that they faked the video, like solid proof.
Oh
like,
yeah,
hey,
I don't doubt it.
you
For a
guys
second they
completely
faked
faked this, kind of deal.
Like,
Not
It's like
something.
it's like Stonehenge. Did you know it was faked? Stonehenge.
Never heard
No.
of no. No.
Never heard that one.
You don't know about Stonehenge?
I know about Stonehenge. I never heard it was fake.
You can't fake Stonehenge.
Yeah, it was. I have videos of. There are videos of trucks bringing rocks to back in the 1920s or 30s.
No.
Yeah, it's all fake.
No, really?
I don't
Stonehenge?
Yeah, I'll send you
What?
links.
What is the purpose of faking stuff like this?
I don't know. I didn't follow the whole story.
Is it just to keep us so occupied with the thoughts of something that's
The
BS?
only person I knew that was able to lift megalithic structures in our modern day is Ed Lee Scallon. He's the only guy that I know when he built the Coral Castle, he was the closest guy, if anybody, that would be able to rebuild the pyramid would be Ed Lee Scallon.
Did you hear they made a Eiffel Tower replica in China?
Yeah.
It's the same size and everything.
Oh, I wouldn't doubt it.
It's in one of the ghost cities over there. Nobody goes there, but there's an Eiffel Tower in China.
Yeah.
Or one of them,
It's probably going to
Shanghai or whatever.
Like they're radioactive cities, the ones that they doomed for all of humanity to use.
Yeah, everybody who owned property there is all going to lose their shirts, all their.
Why radioactive in China? What do you mean?
I don't know. They had like nuclear leaks and stuff like that, so they abandoned these cities, like completely built cities.
You mean these ghost cities that became ghost cities? They were powered by nuclear plants that have leaks.
Yeah, and then they
I did not know that.
so they abandoned them. Yeah.
Well, that makes sense why they're ghost cities then.
Yeah.
They must be covering that up because I didn't hear that.
Yeah, I didn't hear that too. I heard it's because they just bought them for real estate investments.
No, dude. Like I've heard this on even documentaries on TV. Like like these abandoned.
Really?
Yeah, even
Never heard that.
China and Japan and Russia.
Skip my ear.
Yeah.
It's all because of a faulty power plant that was powering these cities. Okay.
Yeah.
Wow.
Like they built these cities, then like the workers, they it had like buildings and like it's a small city, like
No, what I can't understand is when you build a nuclear power plant, the first thing you do is a geological survey of the area. I don't know how many places in North America they built nuclear power plants on fault lines. Now, something's wrong with this picture here. Why would you build a nuclear power plant on a fault? Like, am I missing something here? Like, why would they do that? Even here,
honestly, I think the whole nuclear power plant thing is just an excuse to have products for their nuclear weapons. Like they don't really need nuclear power that much. We don't need power that much. I don't think we're really consuming. I mean, there's many ways to make power.
Even here in Canada, right outside of Toronto, there's a nuclear power plant. It's called Pickering. It's built on a fault line, right on top of a fault line. Why would I can't understand why they would build it on a fault line? Makes no sense to me, and I'm sure there's many others.
I mean, there was power on this planet like literally a half a century or more before nuclear came around, and we were using hydropower, thermoelectric, dam power. What else?
Tidal power. They've been doing that.
Oil, burning oil.
Wind.
No, not until recently. We weren't using wind for at least, the first half century of having power. We were not using wind or solar. We were using hydro, oil, mostly hydroelectric.
Yeah.
Which is very reliable.
Well, if you have the resource, use it, right?
We do. I mean, we live next to an ocean here. They have these things that move with the waves, levers that move with the waves, and they make power. It's just they don't want to maintain anything. They want to build something that's low maintenance, and they don't care what the risk is.
See, with us, we have Niagara Falls 1 hour away from here, where I live. So, we got the use of Niagara Falls, and, we got huge wind farms here in Ontario that a lot of people don't know about.
Ironically, nuclear power is a lot of maintenance.
Yeah.
Yeah, sorry, can I show just
sure.
I just went on my underground network and I uploaded the video of Stonehenge. Do you want me to share it?
Sure.
I can't believe. I still don't believe this. I do not believe this. I'm in denial. I'm admitting it too. What? You sure they weren't just like trying to repair it back then or something?
It's all fake.
Yeah, no, that don't look like repairs to me, man. I'm in construction. I can tell you that's not repairing anything. They're actually building.
Yeah, so there you go.
That's terrible.
Is there anything?
Does anybody?
that's
What did you watch this documentary on this? Did they tell you the reasoning behind the fake? Why they would fake it?
No, I didn't. There's so many news, I didn't really follow this one, but I didn't. I need to dig in and.
What about who? What about who faked it? What organization built that? Maybe they'll tell you why they did it, if you know who it is.
Yeah,
Who
it's
built
all
it?
about that misinformation. It's like the Philadelphia experiment. They like to disinform to confuse the enemy or enemy countries or something like that. So they like to do that. So it's the same pattern there. It's some sort of disinformation to mislead
Espionage.
mislead other people for some reason. But Stonehenge, I don't know why exactly. I
So
can't
you're
tell.
saying it's like a new form of communism.
Yeah,
Build fake Stonehenges. It's better than communism. We don't have to do any work, and you're all brainwashed.
yeah.
Just
What-
put up a fake monument, and everybody's brainwashed.
What about
Great.
like
You don't have to work for it.
Yeah.
The communism that we know, that was a lot of work for them to brainwash everybody. But you do like something like this, and it's not much work. It's just a one-time job. Set it up, and the brainwashing continues on and on and on and on for
Or
centuries.
maybe they want to increase the tourists. The number of tourists to visit their place. I don't know, man. They wanted to create an economy. It's possible as well.
I've heard that being done with ghost, haunted houses and things like that, and get people to go there.
So
Maybe they're trying to feed off the superstitious by faking something like that. Maybe that's some reason to feed off the superstitious population. Which is a huge.
Yeah, I don't know the exact reason, but one thing I do know is the Titanic. Did you know that the Titanic was intentionally crashed?
Yeah, it was crushed because the Astor family was on board, and those guys were adversaries to J.P. Morgan.
Yeah, and the Federal Reserve and all that.
Yeah.
I heard something about that.
Jacob Astor was a big supporter of Nikola Tesla, and he was the only guy at that time that would fund him. So, I personally believe that ship was sunk because the Astor family was on board.
And who's the Astor family?
They were the ones that were basically in the same kind of financial institutions. They're basically competing against J.P. Morgan Chase.
Energy production or what?
No, the monetary system, just taking control of the Fed and the whole monetary system, and then just basically controlling the world, economy, right? And they didn't want to go play ball with the J.P. Morgan, and they met their demise on the Titanic, which I found kind of interesting.
Strange.
I think, and that was right off the coast of Nova Scotia.
I thought it was for insurance because they still had
No,
insurance.
no. They had to get rid of the Astor family. John Jacob Astor III. You can look him up online.
Why they were competing for control of the population. You're saying, basically.
Well, control the monetary system.
Mhm.
Basically created all the fiat money that they have today. Keep
Dollars?
fiat. Yep, that's where it all
Dollars is
started.
way older than the. You kidding me? Dollars goes back.
No, but what they were doing with the Federal Reserve and kept printing money and basically creating fiat currency and creating a system that ultimately would crash, and that's what happened in
Ponzi.
yeah, it's like a giant Ponzi scheme, and they had the Great Depression, 1919, I think it was
So wait,
1922.
J.P. Morgan had their fiat, and the Astor family had their fiat,
No,
and they both were.
they didn't want that system to go through. They were pushing against them to keep more of a more true, safe
Gold.
system. Yeah, like backing all their currency with gold. That all disappeared. Like if you go to Fort
So
Knox today,
the J.P. Morgan or the Rockefellers were gold and not fiat.
no, that switched from gold. It switched to oil.
The Rockefellers, they switched to
Yeah,
oil, right? So
yeah.
they're against fiat and pro real stuff, whatever.
No, they want fiat currency. More fiat currency they got out there, the better, because they know they can make the
So
system crash.
so the Rockefellers were competing with their fiat against the Astor fiat. What was the
Well,
competition here? I don't understand.
no. What I'm saying is that what J.P. Morgan's plan was, to control the
Why did they
Fed.
have to get rid of the Astor family? What was the problem with
They
them?
didn't want this system that would collapse
They
because they
didn't
knew.
want the fiats. They were against the fiats.
That's right.
They wanted
Oh,
to
so
money without having a back gold, like
Right.
gold. They wanted to convert it from gold to oil, petrodollar. This is
well,
what.
Eventually, that's what
J.P.
happened.
Morgan wanted that,
Yeah, yeah.
but the Astor family wanted
Backed by
to
gold.
Yeah, like most of the European,
backed
like
by gold,
backed up by
and
gold,
and
like the
and the
dollar,
Morgan
the
J.P.
ones
Morgan didn't want it. Right?
backed up by the
Yeah, yeah.
petrol.
They were adversaries.
Petrol. Oh, so one wanted it backed by gold, the other wanted it backed by petrol. I get you.
Yes.
Yeah, because when you start backing it by gold, and that's where all the funny stuff started happening, especially when you got into right around 1973, the year I was born. You had the oil embargoes and you had the oil crisis back then. And that's when they took gold off as the trading currency and they backed it by oil, not gold anymore. And that's when the US Fed and Fort Knox, basically all their gold started disappearing. There was no gold
Yeah,
there.
this whole thing with the gold.
Yeah, most of it went to China and the Middle East. That's where most of it is. Like if
Why
you
would
go,
we send our gold there?
well, they just sold it off, so
Safekeeping?
they sold it off so they can make more fiat currency.
We sold our gold to China to print more dollars?
Not specifically China, but China, that's what they did. When the Americans were selling off their gold, China was doing a lot of buying. Right.
Of dollars and treasuries, you mean?
Treasuries, futures, all that stuff. Gold.
China was buying that while they were giving.
From what I understand, China owns most of the gold on the planet right now. Other
Yeah,
than
So
that's how
we were
they're
trading our gold for them to buy our treasuries.
that's why they're currently in the lead for producing microchips. They use gold and produce like all our cell phones, all our computers, all of every piece of
It
technology.
just doesn't make any sense from my viewpoint to give
Of course it's not gonna make
a foreign nation our gold so that we can print more of our own money. That doesn't make any sense to me. Why would we give someone our gold so we can print our own money? It doesn't make sense.
Well, that's why you have a corrupt system. That's exactly what happened. It's totally.
That's like saying, let me give you my value.
Yeah, but then you
so I can inflate my currency by printing more of it.
You force them to purchase the oil in dollars, and then give
to get China to purchase oil in dollars.
Well, at least back then. I don't know if things change now. I haven't read it.
It has gotten so out of control. What's happened with that system that the U.S. dollar.
Oh, that's why we're printing more money. So China has the dollars to purchase the oil with.
it's totally corrupted. You can't.
No, that's
just
why
use-
we have to print more dollars, because we want everybody to purchase the oil with dollars.
Right, and that's why we have hyperinflation right now.
That makes a lot of sense.
Hyperinflation, not just
We're trying to get everybody to do trade with oil using dollars,
Yeah,
not their
yeah.
own currency.
For example, the Russians refused,
And
that
that is the source of
they
inflation of the
European
dollar.
because
Yeah.
they want to
The
trade.
dollars are debt. Understand that now. The dollar system is debt. It is.
What
not
about these other
good
countries that are not printing their money and using our money to trade for oil?
They're buying what they're doing. In essence, they're buying debt.
They're
That's what
using
they're
debt to get the oil.
Yes. See how corrupt it is?
So they're converting their own currency to our currency to then get the oil?
Right. Exactly. They're buying a U.S. debt. Any dollar that the Americans print is debt. It's not.
Well, I can
open.
understand why, most countries, especially third world countries, would rather use a first world currency to do business, because they're like corrupt
See, that-
also, like way more
yeah.
corrupt.
The level of corruption and it is so unbelievable.
I mean, every time you watch any of these economic broadcasts on the economy, they always say, why does everybody choose the dollar? It's because it's the cleanest, it's the cleanest thing in the bucket of dirt.
No, it's all dirt.
No, no.
It's all dirt, but if you pick a coin out of there and it's a U.S. coin, it's got less dirt than all the other coins.
If
See,
you want a nation to have oil, you have to use the dollar. You can't, otherwise you'd be buying it in the black
Because
market.
it's the cleanest house in the room. It's the cleanest, room in the house
See,
or whatever.
one thing I do know, if the U.S. dollar gets taken off the international currency of trade,
They cannot,
no,
because the BRICS nations are 100 times more corrupt. Okay, they've always been ripping each other off. Now they think they can change. So let them do that. They've done this before. They'll just go back to ripping each other off again.
And you think
The whole reason they're using the dollar, the whole reason the BRICS nations have been using the dollar is because they've been ripping each other off. They can't trust each other. If they could trust each other, they wouldn't be using gold either. They'd be using their own currencies. So things are not going to get any better just because they go to gold.
So
they're still going to rip each other off because they can't trust each other with their own currencies. They got to use gold.
Soon enough, all of money is going to become meaningless. Everything is like cryptocurrency is going to become the new money. You know that. It just
they rip each other off at the exchange rate right there, and then they do it wherever else they can do it. They keep ripping along the the daisy chain of the transfer of funds. The first chain in that transfer of funds is at the exchange office, where you trade one fiat for another, and that's where they've been ripping each other off for hundreds and hundreds and hundreds of years. And now they want to, we're all going to go to gold because we're still going to rip each other off, is what they're saying. If they weren't going to rip each other off anymore, they wouldn't have to go to gold or dollars. They'd use their own currency to at the exchange rate, at the fair exchange rate, and they wouldn't rip each other off at the exchange.
Okay,
so I think BRICS is going to fail, 100%.
Yeah, but
they're going to go back to ripping each other off.
You have to have a real value.
But look what the actual price of gold is now today. It's over $2,500.
That's not going to help the BRICS nations any if they have to use gold because they don't trust each other.
It won't help anybody who owns fiat currency. If you want to stay in a stable market, always stay with the precious metals.
I kind of disagree. I think when gold goes up, currencies will either go back to being gold backed, and if they don't, they're going to sink.
No, because right now the currency is so hyperinflated. You have hyperinflation worldwide. Canada.
Yeah, so they can't afford to go to gold back it, right? Because there's
if I were gonna put my money on anything, I would have bought gold when it was super cheap and just sit on it.
You know that there's some currencies that are backed up by, right? Not just gold. Silver is also another, you know, a form of
Commodities.
metal that you know, they use in the monetary world as a backing to, you know, printing money. I think even in the United States, I can't remember if it was like in the 1700s or something like that, but they used silver for a period of time to, you know, and plus silver was in the coins, not, you
Right.
know, so it
It
was,
was used in coins. Yeah.
yeah, so you know, it's its own, you know, monetary system. You know, I
Yeah.
think it was
Well,
like
you
in,
had copper, you had silver, then you had your copper pennies, and then you had your nickels made of nickel, right?
yes.
So they utilized those different precious metals into currency, which that's the way it should have stayed. But you know, the financial institutions had wanted to run their giant Ponzi scheme, and that's why we're in the big debacle that we're in today. And because of all that stuff, look at all the freaking wars it starts. You know?
You know, like copper right now, for every penny, it's really worth 3 pennies in copper, like the copper
Oh
value.
yeah, oh
But
yeah. Copper's gone way up in price.
so, like, if you get like a pound of copper, it's really like,
I think everything's being inflated, like artificially, like even the metals. I think it's all going to go back down. Like I think gold's going to hit 1,500. I remember
That's
when
what.
I was going to buy gold, it was 800. Now,
Yeah,
of course, it goes up and down over the years,
I
and
hope.
it
I
always
hope.
goes up, but it's going to go down again.
If gold crashes again, like if it goes under $1,000, I'm gonna start buying gold. I
It
really will.
crashes all the time. I mean, over the decades, up and down, but in a long span, it's generally up, but not like
Mhm.
parabolic or nothing. It's not
Yeah,
parabolic.
yeah. Guys, I'm gonna call it quits for today. I'm pretty tired.
It's a
Uh,
good reserve. It's a good place to have some reserve funds in gold,
yeah,
but not.
exactly.
It's not
Just
something you want to put all your money into gold because it will crash again.
yeah,
And then
it's a
if you
cycle.
need the money, then what?
Well, the last big crash was 2008, and it goes in cycles, right? So
Yeah, when it crashes, you can't cash in. You got to hold it now and wait
yeah,
till it goes back up again. That could be another decade or
yeah.
two.
So, anyways, we're gonna call it quits for today. Thanks a lot, everybody, for joining us. My panel. Thanks a lot, everybody, for joining the show tonight with me. And program notice next week is Good Friday, so we won't be doing a show until the next following week. Yeah, so everybody have a great Easter if you celebrate it, and have
Happy
a
Easter,
safe
guys.
week.
sure.
Happy holidays to everybody, and we'll see everybody in 2 weeks.
All right.
All right, take care.
See you guys.
Bye.
Good night.
Good night.